First of all, I'm going to ask the students that the problem which I gave you in the previous session on the test of significance of single mean. Probably you have noted down the problem. I hope because you have got enough time, you have taken the screenshot at least. Now in this problem, this is a kind of problem which has very tremendous kind of practical significance, as you can observe. Now, I'm not going to deal with the system right now. I'm actually interested about the technicality of solving the problem. And here I'm going to explain the p-value approach to deal with the hypothesis testing problem. We have to know the proper definition of p-value. But before I come to this particular section of p-value, we shall try to deal with the problem with our usual approach. So what we do, we actually set up the null hypothesis, and quickly I am writing that if we consider the mean burning rate of the propellant be denoted by mu, then this is actually 50 cm per second according to the conditions given in the problem. And if it is so, then the corresponding H1, this is mu not equal to 50 centimeter per second. Okay, and you know from this particular section that this testing is a kind of two-tailed test. This is a kind of testing which is called two-tailed test. Now, I have already told you that kind of statistical tool that we need to use over here. I'm going to use jet test. Why am I going to use the jet test? Okay, you can ask me at this particular stage, you can ask me one question. You are not asking me this question, that is, I mean, this is strange, and it implies that you are not studying at home. You have not started studying yet. But if a person is studying, he might have asked me that, sir, you told us that when n is equal to n is greater than 30, then your sample is a large sample. Okay, and when it is less than or equal to 30, then it is a small sample. And you also told in a previous class that for large sample we use jet test. But here, according to the conditions given, the sample size is n equal to 25, which is less than 30. So it is not at all a large sample. How can I use capital Z then? We need to use some sort of different formula for this. The answer is this: we are actually approximating the thing with the help of Z. Yeah, you are right. Some other small sample tests are there, but I'll be doing the small sample test, you'll get to see that the formula of that small sample test and this formula that I'm going to use over here, they are very similar to one another, with some changes here and there. But since we have not learned about any other formula, and since you can approximate things with the help of any testing of similar kind, then I am actually trying to apply the large sample test on the basis of the given data, on the given data. It could have been much better if the sample size were more than 30, but sample size 25, we can consider it. At least it is not 10. If sample size is 10, then I could have thought no, we shouldn't use the jet test. But since the problem which I have considered from the book, they are telling me to approximate the thing with the help of large sample, actually I am going to do the problem by using the jet test. But here my basic objective, and that what to select and when to select, that can be discussed later on. in some other class. But my point of discussion in today's class is not about what sort of testing I'm using. My point of discussion is about the approach of drawing conclusion on the basis of p-value. So let us take into consideration that, yeah, I'm going to approximate this small sample on the basis of large sample theory, and I am permitted to use the formula of Z, which is given by X bar minus mu by sigma by root n. Now, all the values, X bar is the mean burning rate of the sample propellant, and mu is given to be 50 centimeter per second. From the question, as I can see, X bar is 51.3 and sigma is 2 centimeter per second, and mu is given there, and small n is 25. So you can very well calculate Z. So can I get the value of Z from your end? I will be grateful if somebody gives me the value, because I told you I do not have calculator with me. Please provide me with the value of Z. Thank you so much, Vanchita. It is 3.25, I think. Anybody else getting the same result, 3.25? Please check. I want at least one people. Thank you, Indrajit. So both of you are getting the same value, 3.25. What is the p-value? Now, what is 3.25? Let us try to draw the diagram. When I get, you know this thing, that after you calculate 3.25, after you calculate Z, to draw the conclusion, what you do? As I have taught you in the previous classes, that you need to calculate mod Z, which is 3.25 indeed. And this is actually 3.25 and it is greater than 3. Therefore, H naught will be rejected. No problem with that. And not only this, we can see that H naught is rejected at any level of significance. H naught is rejected at 5% level of significance. Why? Because since 3.25 is greater than 3, it is also obviously greater than 1.96. H naught is rejected at 1% significance level also. Because since 3.25 is greater than 3, it is obviously greater than 2.58. So in all level of significance, it seems to be rejected. So we have this normal curve, and we have this value 3, and 3.25 is lying somewhere here. Say, for example, this is my 3.25. Okay. Now, I'm actually trying to draw the figure in an enlarged manner so that you can see it properly. Try to understand the particular logic which I'm going to talk about. 3.25 is lying somewhere here. And this value is very near to the value 3. Now, on the basis of the sample, you have come across that this value 3.25 has come out. And this boundary is actually giving you a critical value. This is the boundary between the acceptance region and the rejection region. This region is the rejection region, you already know. I'm drawing this region by blue, red color, and this region is this part is the acceptance part. You have to keep in mind that on the left side, -3 is the boundary. So within this, we have the acceptance region. 3.25 is actually falling very near to the boundary between the critical region and the acceptance region. Is it because of the choice of the sample? Is it because of the error made by the experimenter on his part of experiment? Is it because we have chosen the sample size to be 25? Is it so? Is it because will the case be similar? Will the case be similar if we could have chosen a sample larger than something larger? Or we could have chosen some appropriate testing. This testing is actually not giving me the appropriate result because of we are approximating the small sample with the large sample theory. So this value is actually creating a problem. Whenever we reject null hypothesis, suppose if I use a similar kind of situation, suppose this is my situation 1. And now I am dealing with another situation, say situation 2. And here also I'm going to draw the diagram like this. And suppose this is your 3 also, and this is -3. And the problem set up in such a, the problem has been set up in such a manner. Suppose the value of Z is falling over here. Suppose this is kind of 3.92. Suppose. Now this value is also falling on the rejection region. But if you carefully observe the two things, try to compare, that you will see that in this case, the value 3.92 is actually very far from the critical value and inside the deeper inside the critical region. But it is not that deeper into the critical region. It is falling in the boundary. बॉर्डर के बीच में जैसे रहता है ना एक नो मैंस लैंड, मान लो कि नो मैंस लैंड में खड़ा है, थोड़ा सा ऐसे इसमें इसको ऐसे धक्का दोगे तो टुक करके ऐसे उधर चला जाएगा. So why this is happening? The question is it my error or is it okay? So we are not actually satisfied with the approach by which we deal with the conclusion. So some statisticians thought that we have to go for some different approach. We cannot judge it. We are actually confused about the situation. So to rescue us, this approach is sometimes used and it is very useful also. So after all these discussions, right now I'm going to give you the definition of p-value. So first of all, I'm going to write the definition. Then I'm going to do the problem with that. So the definition of p-value is that the p-value is the smallest of all level of significance that would lead to rejection of the null hypothesis H naught with the given data. How can we calculate the p-value? What are the formula? Suppose Suppose your level of significance is alpha, and with this level of significance we are rejecting the null hypothesis. It is a kind of probability, you already know that. So if a null hypothesis is rejected at alpha, this implies this null hypothesis will be rejected, definitely it will be rejected at alpha plus 1, alpha plus 2, and so on. So if I consider this sequence of probabilities, at all these probabilities, with all these probabilities, the null hypothesis is rejected. Out of these numbers, this is the smallest one. That smallest one is actually called the p-value. P-value is also a kind of level of significance. So here is a note for you. P-value is also a kind of level of significance. Okay. Now, what is the formula for doing that? I am going to denote by the notation phi z the probability that capital Z is less than or equal to small z. This is my notation that I'm going to use over here. Remember. Now, if your test is two-tailed, for a two-tailed test, your p-value is denoted by 2 into 1 minus phi of z naught. This is the formula. Z naught is the calculated value of z. This formula will be used if your test is two-tailed. For one-tailed test, and not only one-tailed, if you're interested about the upper tail or right-hand tail, whatever you call it, the formula of p-value will be 1 minus phi of zz. If your testing is one-tailed, but you are interested on about the lower tail or left-hand tail, your formula of p-value will be phi z naught. In my case, it is a two-tailed problem, isn't it? In my case, it is a two-tailed problem. So I'm going to use this formula. Now, we have seen that from the previous page, we have seen that z naught, which is the calculated value of z, it has come out to be 3.25. For this, the p-value will be, according to this formula, since the test is two-tailed, for this the p-value is 2 into 1 minus phi of 3.25, isn't it? Now, by the definition of phi z, this is equal to 1 minus probability of z less than or equal to 3.25. Now, I'm again asking any two students, either Indrajit or Vanshita or Aishwarya, anybody, please tell me, go to my class note 8. If you have downloaded my class note 8, in the class note 8, I provided you with the normal table. From the normal table, you try to get the value of this probability and write in the chat box. Provide me with the value, and then I'm going to calculate the p-value for you. And then I'm going to explain further. Please help me to find the probability of this. I'm referring you the class note 8 on normal distribution. Please go to that PDF file. See the table. Yeah. Thank you, Vanshita. 0.9995. So, Vanshita, you do one more thing. You calculate this. You calculate this quantity and tell me how much is coming. I mean, this quantity I'm talking about. Calculate this quantity and tell me how much is coming. Okay. Okay, no problem. 0.995 or 0.994. Yeah, I'm considering 0.994. No problem. This is pardonable. No problem. Okay. But what is the value of this? I mean, this item. 0.012 or 0.0012. Yeah. Because there are three nines you are giving me. That's why this result 0.012 which you have written is confusing. 0.0012. Now this is your p-value with respect to the given problem. This part is the formula part. Remember, I have used the first formula. I wish thank you. This part is the formula part. So I have given you this formula. I have used this first formula because why? Because my test is two-tailed. Remember, if you are dealing with a one-tailed test, never use this formula. Never use this formula. Diagrammatically, if you want to know what is happening over here, I'm going to explain that thing again to you. Suppose this value is your Z0. Whenever I am writing phi Z0, which is probability of Z less than or equal to Z0, this means I am actually considering this region on the left hand side of Z0. This is the region I'm talking about. By this, whenever I'm writing 1 minus phi of Z0, that means I'm interested about this region. Okay. Whenever I'm writing 2 into 1 minus phi of Z0, that means I'm interested about a region which is shown below. I'm again drawing it. This is the region which is called 2 into 1 minus pi Z0. Okay. So diagrammatically, you can understand what we are calculating. Since I'm actually considering here two-tailed, as you can see in the picture, that's why this formula has been used. Any formula will not work. They will work. If you are doing any sort of mistake to write the formula, you will get some value, but that will be considered as a garbage value. Anyways, so this is my result 0.0012. Now, how to draw the conclusion? After that, what shall I write? I have already told you that p-value is the lowest level of significance. In this problem, we have got the p-value to be, suppose I'm writing the p-value, I'm denoting the p-value by alpha 1, and the value which I have got is 0.0012. Whenever I'm getting this p-value with respect to the given problem, this means the null hypothesis H0 that mu is 50 would be rejected at any level of significance, any level of significance alpha greater than or equal to alpha 1, which is 0.0012, because alpha 1 is the lowest level of significance at which the null hypothesis is rejected. So if you consider, if we consider our alpha to be 0.05, so 0.05 is definitely greater than 0.0012, H naught is rejected. If I consider our alpha to be 0.01, which is definitely greater than 0.012, H naught is rejected. If I consider our alpha to be 0.10, which is greater than 0.012, H naught is rejected. If I consider our alpha to be 0.001, which is actually not greater than, which is actually similar to alpha 1, your null hypothesis is not rejected. Okay, here I will not consider the equality symbol. Any level of significance alpha greater than alpha 1, the null hypothesis will be rejected. So what have we found over here? That the lowest level of significance is this one. Oh no, just a minute. 0.001 and 0.0012. 0.0012 is actually here since I'm considering 0.001 to 4 decimal places. So the thing which I've written over here is actually a bit wrong. I mean, the notation I have used is wrong. 0.001 is actually, I can keep it alpha equal to 0.00. This equality sign can be kept over here, no problem with that. Suppose I'm considering my alpha at 0.0012, suppose, and this is equal to alpha 1, my null hypothesis is rejected. Okay, but my null hypothesis is rejected, no problem with that. But if I consider my alpha to be 0.001, this is actually less than alpha 1, because alpha 1 is 0.0012, it is larger. Then your null hypothesis is not rejected. Okay, I'm considering up to 4 decimal places. So in this scenario only, the null hypothesis is not rejected. In every other case, your null hypothesis will be rejected. So you have to choose your level of significance. So in the beginning of the problem, we actually drew the conclusion, but we were very much confused about the position of the z value in the diagram, whether it is closer to the acceptance region or is it deeper into the rejection region. So this approach which we have done, although it is used, but this approach is actually not very faithful. It is not very faithful. So the faithful approach is this one, because you see that what is the basic difference between this approach and the current one that I have shown you. This approach, you have to predefine your level of significance at certain point, isn't it? Be it 5%. Suppose Vanshita is choosing her level of significance to be 5%, and Ayush is choosing alpha at 1%. Vanshita is getting rejection and Ayush is getting acceptance. Somebody else is setting the level of significance at some other point. different, you may get the same result or you may get the different results. Then altogether, if you do not sit and if you do not discuss among yourselves, you'll never get to know that this is the current scenario, isn't it? So Vanshita has to know what Ayush has got. Ayush has to know what the other people have got, what level of significance they have chosen. But that is not possible, because when you are doing the experiment, you cannot every time call the other person and asking him that what he has done, because it is his research and it is your research. You cannot involve other people into your research. So what you are supposed to do, if you can find out the lowest level of significance that we have done over here, then at least you know a more generalized version that any level of significance which is greater than that will be null hypothesis is rejected, and level of significance less than that null hypothesis is not rejected. So if you want to manipulate your conclusion, you can select your level of significance in a very clever way. If you don't want to reject your null hypothesis, you can select your level of significance in a very clever way, and you can tell the newspaper reporters that this is my conclusion, never revealing what level of significance you have worked on. You can say that now COVID-19 has decreased in West Bengal. Second wave is gone. Level of significance is not mentioned, because general public will never understand what level of significance is. Okay, but suppose you have manipulated the data in this manner. So there is a high chance of manipulation also, if you are not an honest statistician. If you want to be a statistician, my suggestion is always be honest to yourself. See, students, I want to say something. In no book you are going to get this kind of statement. This is my experience, my perception. I'm a teacher. I come to your class. I'm teaching you the subject which is called statistics. Listen to me very carefully. My job is to tell you that my first and foremost job is to complete the syllabus. Every teacher's job is to complete the syllabus. Okay, no problem. Now I can complete the syllabus. I can come to the classroom and I can say that, yeah, students, listen, these are the topics which you have, and in this topic you have binomial distribution. This is the formula of binomial distribution. This is the way by which it is done. This is Poisson. This is the problem. This is hypergeometric. This is the problem. This is hypothesis testing. This is the problem. This is that. This is that. Your syllabus is over. Okay. When I can come to the class and I can explain the things to you properly, that this is the meaning of binomial distribution. In this way, it is done. It is that, this, that. And at the same time, I have to complete the syllabus also. No problem. I can do lots of problems. I can do no problem at all. I can leave every problem to you so that you can solve it by yourself. But what is not, actually people do not put mind over there. I am teaching you a subject which is a very manipulative subject. It's a very highly sensitive subject. Highly sensitive. I am telling a group of 60 students how to manipulate data. Have you ever imagined? I have told you how to manipulate the data. You know how to manipulate, how to play with level of significance. You can select a data and you can choose the level of significance. Since in this propellant problem, you can select your level of significance lesser than 0.0012, and you can accept the null hypothesis. Then you are not going to reveal your level of significance ever to the general public. Who is not going to believe you? This is the finding of this newspaper. This is the finding of that newspaper. This newspaper is saying that COVID second wave is gone. This newspaper is telling that second wave is still on. Imagine the situation that you are reading in the newspaper. What you are reading in the newspaper, do not read from today onwards. Do not read anything on the newspaper just as a general public. Read the newspaper thinking you as a statistician. Do not believe, sometimes believe. Always doubt what is written. Everything which is there, which is based upon data, doubt it. Doubt it. So, being a teacher of statistics, and because statistics is a highly sensitive subject, I must write this line which I have written on the board. This is my primary duty, I think. Whenever you are doing some sort of experiment with data, and because you know, I'm giving you a news, CSE, previously in Techno India, we had CSE branch. And this semester, CSE Artificial Intelligence and Machine Learning has opened. Very soon, they are going to introduce 2 more departments in CSE. One is related to data science. CSE data science. So I am requesting all of you, if you are doing statistics, please do it honestly. Be honest to yourself. On the basis of your findings, everything is dependent. General public is dependent on your finding. You are the boss. You are the God. So never ever distort your data. And if you distort your data, if you do so for your personal, I mean, for your some personal issues or some personal gain, if you distort your data and if you are caught, then remember that it is a kind of punishable offense. So you are learning it's a very highly sensitive subject. So deal with this subject in a sensitive way. Okay, so this is my request to all of you. I hope I am able to communicate the basic knowledge of p-value to you properly, and the message that I want to send to the community of students while dealing with the statistical data, how to read the statistical data and so on. So you have to do it properly. Okay, and students, I'm going to share a kind of book with you. If you find some time, you can download this book from our library Genesis, and you can read the book. You will find it interesting. Yeah, this book I'm talking about, I don't know whether it will open in time or not, or before that. This is the book I'm talking about. Okay, so you just, it is called Naked Statistics. Just try to read the book and you will get to know many things about naked statistics. Download this book from Library Genesis and